um, during the speaker training, they told me to stand in front of the podium, not behind. That's to maybe appear more extrovertic. But though that requires a lot of rock climbing skills, I guess. Anyway, first I would like to apologize for all of these people who are standing there. Um, the intention was to make it a chalk talk, not a full session, such that you can ask questions, and we kind of didn't anticipate so much interest. And also for those who are not even standing there, couldn't get into the room. Also, I apologize for my voice. Yesterday we did the Ask the Expert session, and I was speaking for like 3 hours, trying to speak louder than other 5,000 people in the room. But hopefully I can manage. All right, so my name is Krzysztof Swalina. I work on the .NET team. And last 2 years, I basically spent full time working on the story for managed developers who want to write Metro-style applications. And my talk is on the last day, and we kind of expected that by last day of the talk, I will be, of the sessions, I will be able to just talk about the profile, what APIs are here, but there's a lot of confusion still, like what's happening with managed code, with C# and whatnot. I was monitoring the Twitter streams, and people are asking questions like, can I load CLR side by side with WinRT? You know, does C# compile natively to native code right now? And I was trying to answer these questions, and I found out that the best way to do it is to do a very quick demo. So let me switch to my demo machine. So I'm starting Visual Studio. It's the Plato method of teaching people. You know, Plato's theory of knowledge is that we know everything. Humans know everything about the world. And then when you are born, you forget. So actually, when you teach people something, you don't have to tell them how things are. You just need to remind them. So it seems like when WinRT was born, a lot of developers forgot how C# works. So I'm going to remind you by questions. All right, so I'm creating Metro-style C# grid application. I need a new, is my boss here in the room? I need a better laptop. So I'm starting the process. You've seen this, correct? Those are the demos that you've seen many, many times already. Oh, okay. Let me try one more time. All right, let me try the second version of it. Is that what it is? Okay. Well, let me try. You sure it's not going to work here? Yeah, all right. One more time, grid application. I'm going to change screen resolution as well. All right, the point is I'm going to start an application and ask you, what will you guess? Not this one. What would you guess the loaded assemblies are in the process? Any guesses? There will be CLR loaded and whatnot. All right. How does it look now? All right. Let's see. All right. So now I have the Metro-style C# application running. I'm going here. Let me go to my desktop where I have a prompt. The application is running. And let's do CLS. What did I call the application? Application 5. You see, I tried it like 5 times already. Application 5. So I'm listing all DLLs loaded into the process. And as you can see in here, the CLR.dll, correct? CLR.dll. mscorelib NIDLL. Anybody knows what that one is? You see? Exactly. Just asking questions, and people already know how the universe works. system.ni.dll, and so on and so on. So this is just a short digression, but just to illustrate, from the perspective of managed developers, the runtime environment is the same runtime environment as .NET Framework 4.5. So .NET Framework 4.5 is on the machine. The full surface area of the framework is available to desktop applications. For metro-style applications, we basically have a small subset of APIs. And I'm going to be talking about the subset and kind of explain how we arrived at the subset, what are the reasons for creating the subset, and so on and so on. All right, let me switch back to the slides quickly. So the talk is intended mainly for existing .NET developers. Of course, if you are JavaScript developers, C++ developer, would like to learn about .NET, you are welcome here as well. As I said, I'm going to be talking about what we call profiles. Profiles are basically subset of APIs. And this subset is specifically created for metro-style applications. And I believe that the best way to learn about the technology is through kind of understanding principles of the design of this technology. So I'm going to be talking about why we created the profile, why we chose the APIs that we chose and not the others. And I will very briefly, the sound is very weird. I will very briefly talk about Portable Library project. I know many people are interested and it's related to the profile. And I hope that after the session you will have better understanding in how the system is designed, how the profile is designed. I'm not going to explain everything about the profile. I'm getting a lot of feedback. Everything about how the profile is designed, I'm not going to be talking about all the thousands of APIs that we have there. But I'm going to give you some tools, like how to teach yourself. So when I created this presentation, I frankly didn't even know that it's going to be on the last day. And so I had the first slide and say, hey, voila, we have C# and you can create metro-style applications. But honestly, if that was it probably would be, for some people it would be a yawn, like, yeah, duh. For some people it will be, oof, thank you. But that's not very exciting, correct? That would not be very exciting. But I think what you are seeing right now is very exciting. You should be super happy what's happening in the managed world. How many of you have done pinvoke ever? Yeah. Almost everybody, almost every developer who programs .NET needs to do pinvoke or com-interop from time to time. You just cannot avoid it. How many of you actually enjoyed doing pinvoking and com-interop? All right, I don't see anybody in the room. Yeah, I don't enjoy it either. Jesse, you spent like 8 years working on pinvoke and com-interop. So what is pinvoke and com-interop? It's basically calling native APIs in native binaries and the operating system. Well, this slide shows calling Windows APIs. Some of these APIs are Windows APIs, Windows runtime APIs. Yet, it's very difficult to tell which of these API calls are actually calls to the operating system. Windows runtime allows us to create APIs that feel completely natural to manage developers and JavaScript and C++ developers. That was the objective for the design of Windows runtime. So what can we see here? Well, you can just, as you probably have seen in some sessions, you can just import Windows operating system namespaces. You can use Windows native types in your managed programs. You can create methods that are actually native methods. You can pass managed parameters to native methods. And you can use C# keywords and so on and so on. You've seen all of this, and probably now after 5 days, it's like, oh, okay, that's cool. I have seen some Twitter feeds saying, this is blowing my mind. This is just amazing, and I completely agree. So but when you are programming, the moment you write a single line of C# or VB code, you will be creating a managed assembly. So when you create a C# or VB application, you open the Apex package, you will see some assemblies, exes, maybe DLLs. They will be managed assemblies, correct? When you program in C# and VB, you will be using types, as I showed on the previous slide deck. Many of those will be Windows native types, correct? So 99% WinRT types. 99% or even more types in Windows namespaces are basically WinRT types. Then you will see some types that are purely managed types. So for example, tuple, list of T, system IO stream, X document, and whatnot, they are purely managed types. They live in the same assemblies that they live in .NET Framework 4.5. There will be some types that are managed types, but they are very tightly integrated with WinRT, something like string. So WinRT will be exposing a type that is slightly different, but it appears to manage developers as just system.string. The mapping is done automatically by the CLR. In few places, those who went to Jesse's talk, he was talking about, in few places, the gap between WinRT types and managed types was just too wide to bridge. So we created helpers for you to kind of bridge those two worlds. Jesse mentioned that there are two of those, and kind of from a perspective of you just trying to use WinRT APIs, there are two. You have to just worry about two. Now, from the perspective of you trying to look like what happened in the surface area, can I, like inspecting assemblies in, Reflector or Object Browser, you're gonna find one more of these types, except this type is applied for you automatically by the compiler, and I will show you a bit about this. So in this talk, I'm gonna focus on the blue boxes on the right, not the leftmost green box. That is the surface area of the managed APIs that you will be using. So what are profiles? The most common profile that you probably have heard about is the .NET Framework client profile. It's basically just a subset of APIs for client-side programming. So it removes things like ASP.NET, but it contains WinForms and WPF and so on, and BCL. That's available only on, not in the Metro-style profile. You can see Silverlight as being a .NET platform profile, correct? .NET has a set of, there's CLI standard, there are APIs and whatnot. Silverlight has slightly different implementation. There's different MS-Corlib, but you have a subset of APIs, and you can also see it as a profile. Same with Windows Phone. .NET profile for Metro-style apps is yet another of these profiles. And we represent, so you think like, okay, this is conceptually what profiles are. How do you represent profiles? For those who don't know, profiles are represented by a set of what we call reference assemblies. These are assemblies that don't contain an IL, intermediate language. They don't contain the instructions that let the CLR execute those assemblies, but they contain the metadata. The metadata is used by the compiler to know what are the valid calls that you can make in your programs. So let's say in the implementation assembly, in the GAG, we have MS-Corlib string with lots of members. In the reference assembly, we can have system string, the same type, with less members. And therefore, the compiler will let you just call the subset of the members that are in the reference assembly. So this is how we build profiles. But now, let's say, so this is the technology that we use to build the profiles. And I can actually switch again very quickly and show you where the reference assemblies live for those who don't know. So on your default Windows 8 developer preview machine, if you go to C, program files, 86, reference assemblies, Microsoft, framework. You're going to see this folder called .NET Core. This is the folder that contains the reference assemblies for the Metro style profile. So if I open it, there's a version 4.5 that corresponds to the 4.5 version of the CLR. And if I drill more, I'm going to see some assemblies, and you're going to see lots of assemblies. But there are actually not that many APIs, and I will explain later on why there are so many. All right. Let me switch back to the slides. So this is the technology to create profiles. Now, when we started to create the profile, we thought, OK, what should it contain? Not just technology, but what are the APIs that should be there? And we wanted to create something that is simple, that is well-designed, doesn't have a lot of words and maybe APIs that are too old, and is specifically tailored for development of the Metro-style applications. This profile is not a general-purpose profile. This is not to write any kind of application. This is specifically for writing Metro-style apps. So what are the concrete design requirements? Well, first, and pretty obvious, is that we wanted to remove APIs that are just not applicable to Metro-style applications. Some things are super obvious. ASP.NET is just not applicable to Metro-style application development. But there is always like a spectrum, correct? So ASP.NET, nobody would say, who would say that ASP.NET should be in the profile? Nobody, correct? Console, anybody? Wow, I talked to Miguel yesterday, and he wanted console in the profile. And why is it a spectrum? It's a spectrum because you could actually imagine using console in the profile. In console, you can change the streams from the regular console streams and assign them to any stream, and then you can just use console APIs, correct? There is something that you can do. But the problem with including too many of these APIs in a surface area, in a framework, that are not as commonly used in the targeted scenarios, is that they add little value by being there for those few people, for Miguel, but they hurt a lot of other people. Those who actually don't care, don't want to use it, they just want to write a XAML, C# Metro-style application. These APIs are annoying, correct? You open the system namespace and like console, blah, 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 app domain. You remember .NET Framework, correct? System namespace. It has lots of types. So there's a spectrum, and when you look at the surface area and you think, oh, these features are missing, think about are they applicable, and if this is a borderline, we just chose the line to fall somewhere and give us feedback if you feel that we made the wrong choices. So we also wanted to, of course, remove some dangerous, obsolete, and legacy APIs. And so in .NET Framework, when I say dangerous, I don't mean a huge security hole, but there are some APIs where we recommend that you don't use. FXCAP, if you run FXCAP will tell you don't use this API, be very careful about this API. If you compare strings, you need to pass culture info and whatnot. We just remove these APIs from the profile. So you don't have to worry about many of the gotchas of .NET programming. We removed APIs that are obsolete. That's easy. We removed some APIs that we didn't apply obsolete attribute to, but we consider them legacy. Sometimes we don't apply the attribute because there's nothing wrong with the API. It's just there are no more, let's say there's another API that does exactly the same thing. Or sometimes you cannot apply the obsolete attribute because you cannot apply it to everything. The attribute can be applied to types, members, but there are some constructs that we wanted to remove that you cannot apply obsolete attribute to. Let's say, virtual, correct? Let's say we want to make a virtual method non-virtual. You cannot just apply obsolete attribute and say, please don't override the method. So in the profile, we could just make it non-virtual. That's a very valid change between implementation assemblies and reference assemblies. big part of what changed in the profile is we removed duplication. Another one that is very related, we removed APIs that are very thin wrappers for operating system APIs. Whether they are already in WinRT or not, but if they are very thin wrappers, we just remove them. And the reason is the following. When we created .NET Framework, we were, there's a language runtime, BCL, and then we said, well, people will need to call OS APIs. As you all said, you don't like p-invoking. So let us wrap the OS APIs into nice managed components. And that's what happened in .NET Framework. You had many managed components like event log, performance counters, process component, and so on and so on. I actually was, when I joined Microsoft, I was a PM working exactly on these wrappers. My team was like, you guys are working on the wrappers. Out of college, I was super happy. Well, Microsoft is giving me something more than just brewing coffee. But after a while, I understood that this is a bit of a mindless job, correct? Like, you don't add a lot of value. You just wrap operating system APIs and whatnot. And in the absence of WinRT, there was some value. The value was that you didn't have to p-invoke. You didn't have to deal with com-interop and so on and so on. There was usability value. There are some negatives of wrappers. Like, I didn't understand some of the corner cases in the OS APIs, so I made design mistakes. There's also fidelity loss. There's a loss in terms of the OS team ships new functionality in the APIs, but if we don't rewrap the new functionality, it's not available to you. Having said that, the net value was there. You were getting usability, and you were losing some value because of the wrapping. Well, right now, with Windows Runtime, you are not gaining any value by us wrapping these APIs. You have APIs that look like managed APIs. They are completely naturally consumable from managed code. Therefore, if we kept kind of shipping you wrappers for these APIs, we would be hurting you. We would be giving you something that doesn't have the same fidelity, but doesn't provide additional value. So we removed those wrappers. As I mentioned, event log, performance counters, and whatnot. We also removed duplication for very similar reason. When every component in a platform, in a framework, adds value that is proportional to the number of people that will be using it, overall. Not for every one of you individually, but for all of you, a component provides value proportional to how much you use this component. It also adds cost to you. Every single API that we add to the .NET Framework costs you because you have to learn the API, it increases working set, and so on and so on. If there's duplication in a framework, the value per component is smaller because half of you will be using EventLog v1 and half of you will be using EventLog v2. Therefore, the value of each of these EventLog components is smaller, but the cost is the same. You look at the .NET Framework surface area and you're like, all right, I need to understand what this technology is, what this technology is, and so on and so on. So we remove duplication for a very similar reason, such that the net value benefit for you is as positive as possible. Lastly, we remove some APIs that we consider badly designed. So there's nothing fundamentally wrong with them. They are not obsolete and whatnot, but we've heard many complaints from you that these APIs are badly designed, I tried to use them, and I was really confused. There are not that many of them. We didn't want to willy-nilly kind of start doing massive cleanup, but we did remove some of these as well. So now, these were the design requirements, like what we wanted to have. And then on the other side, you have these forces, and the other force was the compatibility requirements. So first we said, well, running existing .NET applications as is, as are, or even recompiling them without any changes is just not an objective. The reason that it's not an objective is because it could not be an objective, correct? There are some things that just had to be changed. We really wanted these Metro-style applications to look differently, be super responsive. We wanted you to use new storage APIs that are synchronized with the cloud, and there was just no way to accomplish these things without some changes, some subsetting of the APIs. But we spent a lot of time trying to think, how can we make these changes such that it's relatively easy for you to port your existing applications and code binaries to Metro-style apps. You have seen many talks about, XAML portability. We did basically the same amount of work in the .NET profile. We analyzed many applications that are in the Windows Phone application store. We kind of looked what APIs are being used by these applications and try to minimize the changes or compensate for the changes to allow easy porting. Porting is one. Another one that we really cared about is that this new profile feels like just another .NET profile. It's basically, Silverlight is optimized for in-browser development, correct? Media-style applications running in the browser, and now out of browser as well, but kind of LOB space. .NET Framework is optimized for, enterprise and has all the richness, and you can do many things with .NET Framework. Phone platform is optimized for phone development. This one is optimized for Metro-style, yet they all feel like .NET, correct? This one is interesting. This is a slightly different compatibility requirement. This is how it had to work. Early on, we decided that CLR 4.5 and .NET Framework 4.5 binaries, MS-Collib system, and so on, will be used at runtime to execute these applications. Therefore, when you compile to the profile, to these reference assemblies, they live in different directories than the runtime assemblies. Your program needs to be able to execute on the .NET Framework 4.5 CLR. Also, we have in Visual Studio 11, the developer preview, not the Express version for Windows 8 in the full version. You will see a new class library project. It's called Portable Class Library Project. I will talk a bit more about this. The idea behind the project is that you write one binary and you can run it anywhere that there is .NET, like including Xbox. And we, of course, wanted Portable Library to also run in this profile. This is more of a requirement for Portable Library, not for the profile, because the way we created Portable Library, we took all the APIs in the profiles, various profiles, we intersected them, and that is the Portable Library. But just so you know that Portable Libraries can be used in the profile. So after we took the requirements, we spent months, years working, and I'm going to show you the results. So first, some statistics to give you an overview. As I said, we don't have enough time to talk about every single API. You can look at the reference assemblies, but the profile is very, very similar to the Windows 7 phone profile. There are less assemblies, there are less types, there are less namespaces, and so on, but only by a bit. And the reason is that the UI stack in the phone is a managed stack. For Metro-style applications, the UI stack is the Windows runtime, Windows UI.XAML stack. So majority of the difference in these statistics are because I'm not including any Windows runtime APIs in this talk. This is just about the managed stack. But it's significantly smaller than .NET Framework. And I see it as a huge advantage. When you want to write Metro-style app, you want to concentrate on Metro-style app development. So you will see a much simplified surface area. And as I already alluded to, you need to see sorry, this is a slightly different slide. So when you look, we looked at statistics, now let's look at the components. So of course, in the profile, we have the BCL. And BCL changed the least. So when you look at things like strings, integers, collections, arrays, streams, and whatnot, they change the least. And that's probably expected. These types are very generally applicable, correct? Those are the most generic types. Generic not in the sense that they are parameterized, but they are general purpose. As you go higher on the stack, more and more things changed. But we do have an HTTP stack. We have HTTP client API that is a new API in .NET Framework 4.5, and it's exposed pretty much fully in this profile. We also have some very small subset of the HTTP web request APIs. We do have XAML APIs. I know you guys love Xlink. So Xlink is included in the profile. Some of the other XAML API, XML APIs are not included in the profile. Xlink is here. We have serialization. Serialization is slightly simplified, not slightly simplified, slightly simplified. So many of you probably know I work on design guidelines for .NET. And I remember when I was writing design guidelines for serialization, I contacted the team that owns actually serialization, kind of seeking their expert guidance. And I asked them, so, what should people do with serialization? Can you kind of write a draft of the guidelines, and then I will then clean them up, review them, and so on and so on. So they wrote the first set of guidelines. I could not understand this thing, correct? There were guidelines like, if you do this, then use this other serialization technology. We simplified it all. So now there's one main technology for serialization in this profile, and that is the data construct serialization. And I'm talking about the programming model. So when you create types and you want to make them serializable, you need to use data construct serialization. Then you can choose, there are several serializers. One serializer serializes to XML, one serializes to JSON, but there are no more programming models like which attributes do I apply from this serialization model or this one. There is also XML serialization. That is for very specific scenarios where you need to finely control the XML stream that you're deserializing or serializing. But for most part, just use data construct serialization. There's MEF in the profile. How many people are using MEF? All right, lots of hands. I'm happy to see that. So MEF is included in the profile, but Metro-style applications don't support third-party extensibility, correct? Users buy them from the store, and they have the package arrives. There's no way for user to open the package, start adding add-ins and whatnot. So MEF is simplified in this profile to be just an internal composition engine. So I know many people are using MEF for, MEF is kind of two things. It's for extensibility, and it's just an internal composition engine that lets you, wire your view models to your views and wire your kind of internals of your app. The second purpose of MEF is still there. The first one is not. Lastly, WCF from Big Components. WCF, again, it's .NET Framework has one name, WCF, but it's actually kind of two features. You have the server side and you have a client side. I know that they are kind of blurred sometimes in the middle, but in this profile, only the client side is exposed. So you can call WCF services from the profile. You cannot create a server in a Metro-style application. And duplex channels also don't work, which is kind of like a client-server thing, client and server. So this is kind of on a high level. This is the boxology of the profile. Now, of course, this profile needs to be seen in the context of the Windows runtime. So the whole platform is the Windows runtime. and this profile of .NET Framework. So of course, I already mentioned, when you write apps, you need the UI stack. So the profile is not good enough by itself. You need to have UI stack, and you do have it in Windows Runtime. And then there are many operating system services. So I mentioned, isolated storage that lets you, synchronize between different machines, and sensors, and the whole richness of the WinRT that you have heard about during this conference. Very quickly, again, you don't have to actually read this slide, but very quickly, these are the main namespaces. There are some other namespaces in the profile, but they are kind of like for infrastructure. You probably won't be programming to these APIs too often, sometimes maybe, but not too often. But you can see there are collections, there's math, you can use dynamic keyword in C#, and you can use dynamic programming in VB, and so on and so on. Likewise, namespaces have been cleaned up. So I consider the system namespace to be like a window to .NET Framework, especially for new developers, correct? They go and say like, all right, I want to learn about .NET. Let me go to MSDN and see what they have, and they open system namespace, and they see lots of types. Who knows what's the first type when you open, like in MSDN, the system namespace node? What is the first type? Underscore, abdomain, correct? That, that's not a super beautiful window to the .NET Framework. This one, I believe, is. This is this is the system namespace that we would like to have. It contains the very basic types. I kind of collapsed some of the actions. So there are many of the actions and many of the functions, but for the most part, those are the core types. And I excluded exceptions from this slide deck. So there are several, or maybe 20, 30 exceptions in the namespace. So now, I think these are all great things, correct? You have super easy interop. You have a framework that is simple, it's not confusing, it's very difficult to run into a problem when you code against it. There are some things that have changed, were removed or replaced. I would like you to be aware that when you program in this profile, you will run into these issues. And I would like to explain a bit why we remove these APIs and how to deal with the changes. Some of them I already mentioned, system web and so on. So system data. First-tier data APIs for accessing database directly are not in the profile. There's an OData component that you can use to manipulate data. This is a kind of our vision for how Metro-style applications should be. I apologize. Should be dealing with data. OData component lets you basically access data remotely, stored on servers, and so on and so on. There's a talk about OData that probably already happened, but all the sessions are recorded, and at the end of the slide deck, I have session numbers, and one of those will be to the OData talk. Remoting has been removed. There are no subdomains in the Metro-style application processes. Therefore, remoting kind of loses a lot of value. It doesn't lose all value, but as I mentioned, it loses enough value that we felt it's better to remove it. System reflection emit, saving assemblies to your disk, producing assemblies at runtime and saving is just not a scenario. In fact, I'm not even sure whether it will work. So reflection emit is removed. Private reflection is removed, meaning you cannot invoke private members in the runtime assemblies at runtime. Many of you know you're not supposed to be doing this. People from time to time do it. And then they run into compatibility problems and whatnot, and we don't want these problems to be present in Metro-style applications. You imagine the experience of user using their Metro-style applications and a dialog popping up and saying the method is not present. And I mentioned application domain. So those are basically remove technologies. If you're using one of those, you will have to kind of rethink how you're doing these things. It's not a port. Some technologies have been replaced. So if you're using the technology on your left, you will be able to port your code to the technology on the right. And depending on how many calls you have and whatnot, it will be easier or harder. So UI stack, we have a new UI stack. I mentioned the isolated store. So isolated store was one of the hard things. Many applications use isolated store. You will run into this issue. But the Windows Runtime Isolated Store is just a superior technology. It supports, as I mentioned, synchronization between many machines and whatnot. And it's in the system storage application data. Resources, Windows Runtime, the Metro-style processes have new resource model. So system resources namespace now is Windows application model resources. Sockets is, as I mentioned, this is an operating system API service. Our sockets were relatively thin wrapper on top of the API. When you use the Windows Runtime sockets, you will have much better fidelity now and in the future with the OS. Lastly, web client. Web client is removed from the profile. It's replaced with two technologies because web client is actually two technologies. Web client is, on one side, kind of usability API. For the very common HTTP scenarios, you would not use the lower layers of the HTTP stack. You would use web client. But now we have this HTTP client API. It's an API that is optimized for HTTP. And it provides the same or better usability as web client. Moreover, it supports the async programming model, async pattern, and so on and so on. Second part of web client was, I want to download a very large file, and I want it to be downloading, and I will be doing some other things. There's a new technology for it. It's System Networking Background Transfer API. And again, it's optimized for the Metro style process, lifecycle of the processes, where if your process gets swapped, and but you're still downloading something in the background, the operating system will ensure that the right things are happening. Lastly, there are several technologies that they are not removed, they are not replaced, but things changed in them. I already mentioned serialization. Data construct serialization is your main serialization technology. Reflection. I'm going to go into a bit more details why reflection changed. For now, I'm going to just say that system.type is going to be missing lots of members. So when you have, not many applications use reflection probably, or extensively, but if you are, you're going to see lots of compilation errors when you recompile to this new profile. So system type is going to have 5 members. All of the others are gone. The type that is basically equivalent to the system type that you know is called type info. It's very easy. So you recompile your project, you're going to see lots of errors, and you're going to be like, what are they doing? It's super easy to go back to the world that you know of type info. So if you have an instance of system.type, you can just call an extension method called as type info. And it's going to give you a type info. And then you can call like get members, get properties, and this and that. So remember that. XML. So as I mentioned, XML link is there. XML link has some dependencies on XML reader and writer, so they are also there. All the other XML technologies are not in the profile. So XML DOM is not in the profile, XPath is not in the profile, and so on and so on. This is based on the analysis of many existing phone applications, where basically people either use the very nice, convenient XML link API, or they use the very low-level XML reader and writer for very performance-sensitive and for kind of passing XML data around. The other technologies are really not used that often, especially XML DOM APIs. Collections. So collections are when we shipped .NET Framework 1.0, we didn't have generics. So we added collections that were not non-generic collections, like ArrayList, you know. Then generics were added to CLR in .NET Framework 2.0, and we added another set of collections. And now here's a confusion. I had to write blog entry that is like the most read entry in my blog, which is, you know, what is the difference between these collections? Which one corresponds to which? And I say, array list, all right, the new one is list of T. Don't use array list. It's like, for some micro benchmarks, 3 times slower than list of T. You know, many people think like, oh, generics is gonna be slower. No, list of T is 3 times slower when you just for each versus array list. Therefore, the non-generic collections are removed from the profile. You only have generic collections, and I'm talking about the data structures, the concrete data structures, not the interfaces. There are some non-generic interfaces because there are scenarios, like for example, data binding. Data binding cannot work without iList. Lastly, threading. Threading, one namespace, again, 2 different features. One is I'm gonna be creating new threads, manipulating threads and whatnot. Second one is synchronization, correct? So synchronization primitives and everything related to synchronization is still in system threading namespace. Creating threads is not. The reason is, again, we want to ensure that battery consumption and other aspects of the Metro style processes are controlled by the operating system to ensure, again, battery power consumption and kind of fluid interface. So you can kind of create new threads using tasks. So you can say task.run. That is your way if you need some background processing. You cannot just say, hey, I want to create my own thread and hold to it. Last thing, it's not that APIs changed, but frankly, so I was talking about changes in the APIs, like this is changed, this is missing, and whatnot. The main change that I would recommend that you look into and you learn about and you get good at is the new async model, async programming model. I think this will be the largest perceived change after the initial hit of like, I'm trying to recompile my app and I get some, you know, compilation errors. You're gonna get past that. Especially when you start a new application. So you start a new project and you're starting writing new app, you're not gonna see a lot of like, oh, these things are missing. That's I think so. But the async model will be something new. I recommend really that you watch all the sessions about how to use this effectively, how to use the await keyword, and so on. Very quickly, on the Windows Dev Center portal, there's already a portability guide we started to write that tells you, you know, this is what this is the API that you use, this is the new API that you should be using right now. Go and read this documentation. And we're gonna post a blog on the BCL Teams blog, kind of linking to this documentation, this official documentation. Lastly, don't try to call APIs that are not in the subset. I'm not gonna say how to do it, but you are smart. There are some smart people in the room now laughing and saying, you use at runtime this, you know, .NET Framework for assemblies. Don't try to call these APIs. If you call them through hacks, you're not gonna be, there's gonna be a tool that verifies applications before admission to the App Store. And as you've seen in the keynote, it says like, first part of the process, 3 hours, 4 hours, or something. Well, if you use those, it's not going to be 3 hours. So very quickly, Jesse was showing some of these, so I'm going to go quickly so you can ask questions. These are the helpers that let you interop with some of the Windows Runtime APIs that are not as trivially useful from managed code. One is iBuffer. iBuffer interface does not have implementations, public concrete classes, either in this profile or in WinRT. So the way to do it is to use an extension method. If you want to call an API that takes iBuffer, this is the extension method, Windows Runtime Buffer Extensions, sBuffer. This is how you use it. You just take a byte array, you call sBuffer, and now you have an instance of iBuffer, and you can pass it to Windows Runtime API, and vice versa. This is the one that Jesse was not really talking about. You don't have to worry about it. You're never going to be calling this API, but if you see this API, I wanted you to understand what's happening. So Windows Runtime asynchronous APIs don't return tasks. You know that. They return operations. But magically, you can just call await on it. And what is happening is the compiler actually calls for you an extension method called getAwaiter. This is an extension method that you will see in the profile. You never have to call it yourself. Correct? Compiler just applies it for you. This is the definition of the method. Stream interop helpers, again, the bridge between System.io stream and Windows Runtime streams was just too large to gap automatically by the runtime. Therefore, you cannot just pass Windows Runtime stream to XML, XDocument load method. It requires System.io stream. This is the definition of the method load. So there's an extension method called asStream. There are several overloads, and they take the WinRT, iInput stream, iOutput stream, and there's another one, seekable stream, and convert to System.io stream. This is how you use this extension method, and it will probably come in handy in several cases. So I already showed you the folder with the reference assemblies. Very quickly, when you go to this folder, you will see lots of assemblies. And Christoph told us that the surface area and the number of assemblies is very small. What is happening? Well, many of these assemblies are not real assemblies. So you will see things like mscolib that look like this is a real assembly. You will see system collections.dll, and you think like collections are in mscolib. Why do they have a separate assembly for it? And maybe even worse about things like this system reflection below. It's not, you cannot actually see it on this screenshot. Let me first explain why we did it, and then I'll tell you how we did it. What we didn't like about our .NET Framework implementation is some of the, frankly, badly managed dependencies between some of the technologies. So this is a graph of dependencies. You don't read it, don't try to read it. I cannot read it standing like here, correct? We did manage dependencies when we created .NET Framework. We managed the dependencies based on layers. We have several layers in the platform, and the dependencies between layers are very carefully managed. So like mscolib does not depend on ASP.NET and whatnot. There are some places where, in retrospect, we made a mistake. We basically did not separate some features that now we wish we separated. In this new profile, we wanted to fix this. So this is the corresponding dependency graph in the profile. And as you can see, like some of these things maybe look like a cycle, but they are not. There are no cycles in the dependencies between the assemblies in this profile. Most of the assemblies depend just on this very low level. The lowest level assembly in this profile is called systemruntime.dll. That is your new mscolib. System reflection is a separate assembly. This is one of the dependencies that we wanted to break. Two dependencies that we don't like in the .NET Framework are from system object to reflection, because system object is a super simple type, and reflection is quite large. There are lots of types there. Second is from system string to globalization. Again, system string, very, very basic type. Globalization, lots of types, including like calendars. We broke those two dependencies, and we kind of refactored the assemblies to have very clean architecture. So the way we did it, I will be answering questions after the section, and I will go actually to to the Visual Studio booth. If you're interested in how we exactly did it, I can describe it. But let me go quickly here. Basically, what happens is the assemblies that have like nice names, system collections and whatnot, they actually contain the reference assembly, the reference APIs. They will have the collection. MSCollib here is empty. It contains type forwarders. You don't have to actually worry about it. It's just for the designers, XAML designers and design time experiences. All the APIs are in these nicely named assemblies that correspond to feature areas. System runtime.dll is the lowest level assembly, and then you have additional features. Lastly, I mentioned portable library project. Go get the full version of Visual Studio and try it. You can create portable class library using this project. And then you can actually, the project creates binaries. Not like sharing source, creates binaries that you can share between multiple profiles and environments that contain, that run CLR. Here's how you select targets. The Windows Metro style target is now called Windows tailored. In your profile, I mentioned like we wanted to create a tailored subset for Metro-style applications. So this is kind of like a code name, early name for this target. Lastly, for more information, as I said, async, the first section, async makes simple in Windows 8. You need to watch this section. Using Windows Runtime from C#, that was Jesse's section. Many of you have probably seen it. You should watch it too. And of course, you probably are interested in the UI stack, so watch the XAML sessions and some sessions as well. And now I'm gonna quickly take, thank you for staying and wanting to learn about .NET in Metro style. And I'm gonna take questions. And if you could actually go to the microphone to ask questions so the people in the hall and on the camera can listen to it. Thank you.
Can you elaborate more on the decision to remove reflection.emit? Like in the Silverlight model, there's a lot of useful scenarios where generating code on the fly is a good thing to produce, optimal things of like, math type applications and stuff.
Yeah. So the question was about reflection emit. Again, there are two aspects of reflection emit. Well, we have LCG is still in the profile. So you can, at the runtime, generate method bodies and execute them.
Okay.
What I meant by reflection emit is you cannot create in-memory assemblies with types and whatnot and then save them to disk. This is what we didn't want to do. The reason we didn't want it to allow this is first, it's not really a Metro-style scenario. Like, well, you're going to be writing a Metro-style compiler, correct? Then you would use it. And like, when I say there are no scenarios, there are always scenarios. It's just we wanted to optimize. Right now we have lots of work, and like thinking how reflection emit will work in this new Apex package where the assembly is being saved was just something that we didn't focus right now.
Is it closer to what Silverlight has currently as far as being in-memory generate?
I now forgot exactly where is the bungee. Silverlight does not let you save assemblies, but lets you generate types in memory, correct?
Correct.
Is that what it is? Yeah, I know. That was something that I was talking with Miguel yesterday a lot. He was complaining about the exact same issue. We will look into this. I don't promise anything, but maybe there's a tweak where not only LCG is enabled, but you can create types in memory. You cannot just save them. And that's probably what we really don't want you to do.
Right.
Okay. Another question from this side, maybe.
Concerning changes to the design of system type, are those changes also being brought over to the full .NET 4.5, or is that going to remain with the older API style?
Yes. So the changes are brought up. Every single change that I was talking about is in .NET Framework 4.0.
So the refactoring and everything else?
Because they are the same binaries that we use at runtime. So there's the same CLR, there's the same MSColib, and so the binaries are the same. So if type info exists in the Metro style profile, it has to exist in .NET Framework 4.5. Now, the refactorings are not there, because the refactorings are only in reference assemblies. They are not in the implementation assemblies. This is similar to, in the OS, there's this concept of API sets. I don't know if you go talk to Rusinovich. He talked at last PDC about this concept. We refactored the reference assemblies, not the implementation assemblies. The reason was that, frankly, it's more important for reference assemblies. Implementation is now abstracted from you. You have no access to the implementation assemblies. You compile it against the reference assemblies. We can now change the implementation assemblies however we want in the future. We can optimize. We will notice you loading these types but not these. Well, we can split the implementation assembly into two, engine this one but not that one, and kind of keep optimizing the performance of the Metro style applications.
Thank you.
If you develop a WinRT component in C#, and you use it in a JavaScript Metro-style application, is the CLR loaded in that JavaScript application too?
Yes. So as I said, the moment you write single line of C# code, your thing is going to load CLR. It doesn't matter how it's used, in what environment it's used. C# requires CLR. C# is garbage collector, requires garbage collector. The JavaScript engine will not be executing MSIL.
Yes, is WinRT replacing Silverlight?
WinRT is WinRT is not replacing Silverlight.
Okay. So, Metro-style apps, if you're to create an app on the desktop, would you go Silverlight or Metro style?
I would say the following. Do you want to write Metro style application? Correct? Do you want to write an application that is full screen Metro style? Well, then you use Metro style framework. You want to write your classic Silverlight application. You should use Silverlight to write the classic Silverlight application. There's many people are saying is Silverlight replaced, is it gone, and whatnot. It's really difficult for me to answer because were you saying is Silverlight gone when phone was released? Yeah. Phone was for phone scenarios. This is for Metro style scenarios. It's just new optimized platform for it.
Okay.
Yeah.
Hello. I've actually two questions. First of all, you mentioned that WCF does not support duplex bindings.
Mm-hmm.
Is it also true for WebSockets duplex connections?
I don't know. You should talk to the WebSockets. So WebSockets, talk to the WebSockets team. They would know the definitive answer. I was on some email threads, but okay. I don't remember exactly.
Okay. And what is the strategy for offline data storing, like SQL Compact and WPF applications?
Yeah, that is a very good question. So as I mentioned, we have data APIs. They are for the remote data access, OData APIs. They are not in the profile, by the way. You should go to the talk to check how to get it. It's an out-of-band component. For local data storage, the answer is either use one of those application data storage, isolated storage-like features in WinRT, or use the file system. Yeah.
So you showed system.dynamic, and so I guess that means call sites and that kind of stuff. But what about the rest of the DLR? Is that accessible?
No. Okay. So only the low-level dynamic binders are there, not, I want to write my dynamic language in managed code.
Okay, thanks.
Yeah.
Would existing .NET 4.0 assemblies be able to be loaded into the Metro style app, or do they need to be recompiled with the changes? So the first one would be if I'm not hitting anything that's changed, if I've got something that's just dealing with.
Yeah. So if your existing .NET binary, it happens to not call on the other APIs, it may or may not work. But I would just not recommend doing this. If you want to share binaries between various .NET platforms use portable library project. Just recompile portable. It will tell you whether you're using the right APIs. If you have an existing binary and kind of try running it, it may run today, not run tomorrow. You maybe have problems with certification in the Windows Store. I would just not recommend doing this.
Yeah, and do the changes to reflection, it looks like it's probably going to break most of the IOC containers out there. Is there still enough there that I could write, or the people who write these IOC containers could?
Yeah. So as I mentioned, there are changes in reflection, but it's not that functionality has been removed. Very small subset of functionality has actually been removed, like you cannot do private reflection. But many of the changes are just, you need to use this extension method to get you back to the full reflection from system.type, which now is just a type reference. So maybe I will elaborate a bit more on these changes. I know people are interested. System reflection is actually like, again, 4 technologies named system reflection. There's runtime type identification, like I have an object, I call getType, I want to know, are you a string, are you an int, are you this or that, correct? There's this thing that people call introspection. I would like to look at a type and say like, what members do you have, what do you inherit from, and so on and so on. There's dynamic invocation, which is now I have a member, I want to call invoke and actually invoke things. And there are some other things. There's also like part of the reflection system that is actually related to the loader. Like when you say, is assignable from? Well, you cannot determine that just based on metadata by reflecting on objects because, well, it actually depends what you have in your config system in terms of, publisher policies and whatnot. So what we wanted to do is make system type to be just the first part of reflection. It's just for runtime type identification. It's a very simple thing. You can ask an object what type it is, what's its name, I'm system string, and that's it. If you want to do introspection, dynamic invocation, and so on, it's type info. And as I said, we provided extension method to go from one to the other. So I haven't tried existing IOC containers to port them to this profile. I think it will work. If it doesn't, give us feedback. I would be very interested in the feedback.
Very important use case.
Yeah.
Will there be a profile that features the full .NET framework, but that also includes these refactorings that you've made in the future?
It's very difficult to tell. We would like to make some of them. I just wonder whether the value versus the cost, again to you, is net positive for the full framework. This is the same thing with all the things that I was talking about. When you have a smaller profile and you already cannot ensure 100% compatibility, it maybe is worth it. Doing it for a platform that is very widely used, it's very successful in enterprises and whatnot, some of these things don't, net benefit is not there. But we will look into it. Maybe it's there, maybe it's not. Again, give us feedback how you feel. Mm-hmm.
So like any other .NET developer, I have years of library code that I went back and tried to convert into WinRT and Metro UI right after we got these tablets, and surprise, surprise, much of it didn't work. It's very hard right now to figure out sort of how to take something that existed in .NET and find the equivalent and implement the equivalent. Do you guys plan to release more documentation? I know this is very early on where you can say, if you're using web client, here's how you do it with HTTP client, with sort of normal design pattern, this is your old way, this is the new way to do it, because that would be tremendously helpful. Trying to get anything running right now is a little bit frustrating for a .NET developer.
So I had to run a bit quickly through the slide deck, but I had the slide deck about this portability guide. I think this is exactly what you're looking for. And as you mentioned, it's now very early on. We started to write it maybe like a month ago, and we write it based on feedback from people, initially internal in Microsoft groups, like people were trying to do the same thing that you did, and they were asking, oh, this thing is missing, what do I do? So we started to write this portability guide. Initial version is already there on the Windows Dev Center site. Just go to the .NET section.
Yeah, I use that.
And it will be growing.
Okay.
Yeah.
Great.
So the way I understand it is the WinRT is just a type forwarding to a smaller subset of the .NET framework. Is that correct?
WinRT is not type. You said type forwarding.
Yeah.
You mean? Oh, okay.
The assemblies just have the
Yeah.
types in them. There's no actual implementation.
Some of the assemblies in this folder, they only have type forwarders. Some of them actually have APIs. So system runtime.dll will have system string APIs. MS-Collib will just have a forwarder to system runtime.dll.
All right. I guess my question would be, we have a pretty big .NET framework ourselves where people have used. Would this approach be something that we should try ourselves, or could we try ourselves?
You would like to accomplish the same thing that we accomplished in the surface
Right.
area, decouple some dependencies
Yes.
Without breaking kind of compatibility with the internal implementation existing
Exactly.
clients. Yeah, I think you can use the same technique. Go, talk to me. I'll show you. There are some places where it's a bit complicated. It's not as simple as type forwarder here and there.
Right.
I can show you on a board kind of how it's designed. Yeah?
Okay.
Some of the capabilities of WinRT would be really nice to have very generally in .NET, even on the server side, such as the sockets and networking stuff, some of the diagnostic pieces, the non-UI parts of WinRT that are more closely tied to the OS implementation. Is there any chance that those APIs will actually come to full .NET?
You should ask the WinRT team about this. I mean, those are their APIs, and I kind of don't want to speak about their future plans.
And
Mahesh is saying that the networking APIs can already be used outside.
I can't hear anything you're saying. I can't hear anything you're saying, so.
He's saying that you can already use, for example, networking APIs outside from desktop apps. They will publish a whole set, like a list of which ones are supported and which ones are not.
Also, I just wanted to make a comment. The WinRT stuff is very cool, but at the MVP summit, we just kept hearing this word convergence, 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 like there was going to be some unification of things. And what I'm seeing here is more divergence. And as an open source developer, where there are literally thousands, maybe tens of thousands of apps using my stuff, I mean, as soon as WinRT is announced, I've got people tweeting and emailing me saying, when is your framework going to be working with WinRT? And I'm already supporting 3 or 4 different profiles, and it's getting just ridiculous, the conditional compilation across these things. I mean, is there any kind of long-term goal to, patch things up a little bit more?
So, which platforms, which unification?
Silverlight, WP7, WPF, WinRT.
well, actually, so
XNA.
I'm working on, the portable library project. I was working on this project. One of the visions for this project was exactly what you are saying, which is, can we start getting the core of .NET platforms closer and closer? We've done just an enormous amount of work in like Xbox, Silverlight, this and that, to actually make the portable library subset a reality. It's a first step. It's a small step. I don't know if you looked into this project.
Well, I can't use it because I do a lot in the UI space. So, I'm just talking about even just, there's all these little nuances that are just slightly different between, even when the API is the same, the behavior is different with, say, like pack URIs between WPF and Silverlight. And there's just, it's like two people went off in different directions, and they kind of looked at the end result and didn't talk. And
I hear you. We needed to start from the BCL, correct? Like you cannot unify things at the top of the stack before having things unified low on the stack. Portable library is the first step, and we will see how it goes.
Let me just encourage you to keep up with that.
Thank you.
Just another question. We saw that system.data is removed for this profile, and the only thing that make me afraid of for metro style applications, they're not oriented toward line of business. I mean, a lot of our customers ask for tablet applications, and with this API, we couldn't have an efficient local storage of data, of relational data, and I'm a little fearing that we will not be able to make business applications with the Metro platforms with this first release.
Yeah. So, you know, it's all software. So I wouldn't say like you cannot make line of business applications, correct? It's like you're saying it's going to be harder probably that you expect. Yes, the focus of this release was on Metro style apps. Some of the LOB applications probably will be harder to write. For some of these, maybe Metro style profile does not make sense. Maybe, you know, this is why we still have a phone, because phone framework is the best one for developing phone applications. And for different scenarios, there are different subsets of the .NET. Moreover, you should probably speak to the WinRT team. They basically own the overall platform. Correct? This is like one of these boxes that was very small in the big diagram of WinRT platform. Overall, they would probably give you some guidance on how LOB applies to this platform. But as I said, there are some, there's Silverlight, there's desktop applications in WPF. They are not changing.
Yeah, but with Metro applications, we have for free all the touch UI and all this kind of thing that are also harder to make in WPF or Silverlight, because the API are very low level for these platforms, and there is no subset of controls dedicated to touch, so it's quite painful to make touch applications in WPF.
Yeah, let's, this is like a longer discussion. Let's chat we can chat more in the Visual Studio Expo hall. So good. All right, thank you very much. One more time.